Hello once again. Our topic for today is looking at systems of linear inequalities. All right, so we've been talking about systems of equations and we've been talking about linear inequalities. So now we're combining the two. So when we had a system of linear equations, this is where we graphed two lines and we were looking for everything that they had in common. And everything that they had in common ended up being only a single point or an ordered pair where they cross. Okay? But now what we're going to do is we're going to take this idea of graphing linear inequalities. So maybe I'd have one that's shaded like so, and maybe I have another one that looks, well, like this. Okay, so now, just like we did with our system of linear equations, we were looking for everything they had in common. Now this one was a single point, but here we have an entire shaded region that represents both of these. Okay, because this was represented in blue as part of the first and represented in red as my second. So every single point in this region is a solution. So when we're working with inequalities, we no longer have a single point that's an answer. We have an infinite number of solutions, and this is represented by an entire region. So what does this look like when we graph this? Well, we're going to graph this, for the most part, exactly the same as we did when we were just working with graphing linear systems, and then combining this idea with what we just talked about, which is graphing inequalities. So our first one here, we have a y-intercept of -1 and a slope of -3. So from here I'd go down 1, 2, 3 over 1, or I could say up 1, 2, 3, left 1. Okay, so now I know my line's going to go here, but again, I got to check. Solid line or open line. It's going to be solid because of the equal to, so I can draw my line. Okay, and now again, I want to figure out where am I shading. Okay, so this is my y's are greater than, it's probably above, maybe it's tough to tell here, so how about I choose a point that doesn't go through, like 0, 0. And if I plug that in, I would get 0 is greater than or equal to. -3 times 0 is 0, minus 1. All right. So I get 0 is greater than or equal to -1, which is true. Now, we could go ahead and just shade this right away, but what you saw in this last one here is when I started shading everything, it got really messy. So here's what I'd recommend, is just put a couple little arrows here along your line, pointing to the direction you want to shade. And we'll come back and shade in a second. Now let's move to my second line. I have a y-intercept of 2, and a slope of 1x, or 1, so I'm going to go up 1 over 1, or down 1, left 1, down 1, left 1. I do not have the equal to, so this is going to be an open, dotted, dashed line, whatever you want to call it. And now, all right, which way am I going to shade? Okay, well, would 0, 0 work here? Plug in 0 for y, 0 for x, 0 plus 2 is 2. Is 0 less than 2? Yes. So everything on the 0, 0 side of the red line works. Now, the last thing we have to do, because it is an inequality or a system of inequalities, so we have to figure out where we are going to shade. Well, where are both shaded areas pointing to each other? I have red arrows going this way, blue arrows going this way, so this region right here represents all of my solutions. All right, we'll do another one here. Why don't you guys go ahead and try and pause your video and see if you can do this one on your own. All right, I got mine to look like this. So our first equation, I went ahead and solved that for y and came up with this. So I had a y-intercept of -3/2, and then my slope accordingly. And my second one, that was my red line that I graphed. And then, of course, I just went ahead and shaded my solutions when I was done. Last example I want to look at today is looking at having more than 2. So now we have 3 inequalities that we want to satisfy. Okay, we can still do this the same way. So first of all, we're saying our x's are less than or equal to 0. So x equals is a vertical line. We have the equal to, so it's going to be a solid line. Okay. And now we're saying less than 0, so that's going to be everything to the left. Our next one, I have y's greater than or equal to 0, so that's a horizontal line at 0. Again, I have equal to, so that's going to be a solid line. And now I want everything bigger than that. So now, hey, I've narrowed it down to this range here. I know it's going to be somewhere over here. And now I have to throw in my third equation. Okay, so I could solve this for y, or like we've done before, when it's in what we called standard form, I could plug in some points. If I plug in 0 for x, this would go away. I'd get negative y is negative 2, so positive y is positive 2. Similarly, if I plug in 0 for y, this goes away. I get x is negative 2. So I'm at 0, 2, and negative 2, 0. I still have my equal to here, so it's going to be a solid line between these points. Now, which way do I shade? All right. Well, would 0, 0 work? If I plug in 0 for x and 0 for y, you get 0 is greater than or equal to negative 2, which is true. So I'm going to shade on the 0, 0 side, which means it would be this direction. All right. Well, with our blue and our red lines, we said it already had to be in this quadrant here, and now this one says it's going to be here, so we are shading in our triangle for this one here, and that would represent our solutions.